Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
My name is Abdul Montakim. I'm editor of Robotics and Automation News.com. I'm here. It's my great pleasure, actually, to be talking to Ricardo Tellez, CEO of TheConstructSim, the very well-known robotics simulation program, which is online and available for use without special software, just through the internet, which I find very amazing and a great achievement. I'll ask him about that in a minute, but first I thought it'd be interesting to hear Ricardo make a presentation about something new called ROSjects, which I don't know much about, but I'm sure Ricardo will tell us. Go ahead then, Ricardo.
Oh, thank you very much. It is my pleasure to be here, to be interviewed by you. And so just wanted to introduce the concept of the ROSject. That is one concept that we have presented at the last ROSCon, that was at the end of September. And then you should be seeing now my screen now. I have prepared just a very, very short document that shows what a ROSject is. And the concept is to create reproducible ROS projects. That means that I'm going to create a ROS project containing code for the robot, simulations, data set, instructions with lessons, everything together into a package that it's a ROS project, and that this can be executed in any other computer in the same conditions without having to do any setup in the computer of the other person. So that's very interesting in the case that you want to create some experiments with robotics, and then you want to share this with somebody else. For example, you're a teacher and you want to create some lessons with the lessons here with the code, some templates for your student, and then you attach a simulation where this code is going to be tested and executed. And then you provide this to your students. Your students will have the same code, the same simulations, and they are going to execute on a web browser. So they don't have to set up anything, and it's going to work even if they are having a Linux machine, a Windows machine, or a Mac machine. So basically, that's a ROSject. And the ROSject, what is interesting is that they can be shared. So they require no setup at all when somebody receives the ROSject, so doesn't need to do any setup. It can be executed on any computer. So if you receive a ROSject from somebody, you can just press click, and then you will execute the same thing as the person that has shared the ROSject with you. And also, as I said, it can be shared just with a web link. So whenever you create a ROSject in our platform, you can share this ROSject with anybody else, and just by providing a web link. The people will click on that link, and they will automatically receive a copy of the ROSject containing the code, the simulations, the notebook, the data set, whatever you have put inside there. And that's very convenient for sharing code, and especially for reproducing the results of others. Basically, I wanted to share with you this super nice project, the concept that is called the ROSject.
Thank you very much, Ricardo. Let me, if you don't mind, I'm not a programmer. I don't know how to code. So,
Okay.
Some of it will be difficult for me to understand. I'm sure the audience will understand. I also want to start with the TheConstructSim, because that's the first time I came across your company and heard about you and things like that. And I find it just such a brilliant website.
Thank you.
Really, as well as in terms of functionality. I joined, and I tried, looked around and tried a few things. I didn't obviously achieve very much, but that's because of my limitations in programming. But describe, if you don't mind, for a person like me, what the TheConstructSim is and what it does, and what the kind of opportunities it provides and how people are using it, what kind of people are using it, maybe, just an overview of the ConstructSim.
Yeah, sure. Sure. Basically, the ConstructSim is the name of our company. Okay. And inside this company, we have developed a product that is called the ROS Development Studio. And the ROS Development Studio is just a development environment for ROS programs. But this development environment for programming, I mean, it's on the web. So you don't have to install anything on your computer, and you don't have to install ROS in your computer. You don't have to have any special setup, just a modern web browser, and that's all, Firefox or Chrome. So you get in there, and then you can create your programs there. There is an IDE, a modern IDE with auto-completion. You can create your programs. At the same time, you have simulations of robots, of ROS-based robots. Like, for example, I show you the Sawyer robot, where you have fetch robots, humanoid robots, wheel robots, drones, whatever. And so you can create the program and test it at the same time on the simulations and see the results. And then afterwards, you can transfer this into your real robot if you have it. So basically, the ROS Development Studio is the tool that is allowing us to create the ROSjects that I have mentioned before. So whenever you go to the ROS Development Studio, you decide to create a new ROSjet. A ROSjet is just a ROS project at the ROS Development Studio. And this ROSjet contains the code, contains simulations if you want to create and you don't want to use the already provided by us, and can contain also data sets that you have generated using the simulations or by a third party, and then you upload it there. And it also contains notebooks with instructions. For example, we use the ROSjects a lot at the university. I give some classes about robot navigation and ROS at the University of La Salle in Barcelona. And there, when I go there, I just prepare some ROSjects. And at the beginning of the class, then I provide a web link to the students. And when they click on that web link, they will get a copy of the whole project, of the whole ROSjet that they have created, with instructions, with the simulations, with some templates of code that I provide to them, so to make it easy for them. And so they get exactly the same thing as I have prepared. So if I know that it is going to work for me, so I test it, it works for me, then I know for sure it's going to work for the students. And the students doesn't have to change their computer. Many students, they come with Windows machines or Mac machines. They don't have Linux, and they don't want to install a dual boot or else, but they don't need it. They will use the web browser. We also do every Tuesday, for example, every Tuesday we do a live class on YouTube. That it's free class, it's for everybody. It's teaching about ROS on a live class on YouTube every Tuesday at 6 CET. And then at the beginning of the class, let's say we talk about reinforcement learning using ROS. So at the beginning of the class, I am on the chat, I put the link of the ROSjet I have prepared. So all the attendants from many, many places of the world, they click on there and they get a copy and they start executing at the same time as I am doing on the live class. They are executing the same steps because it works for them in the same way it's working for me. So basically that's the product that we have created at the TheConstructSim, the company. It's called the ROS Development Studio, and there you can create ROSjects that you can then afterwards share with somebody. There are some companies that are using the ROSjects for creating their documentation. So for example, we have Robotics company, is the creator of the Dynamixel or the Darwin robot, humanoid, small. So they are using this for creating some projects that teach their Turtlebot 3 robot how it works. So you can go to their website, do a click there, and then automatically it will open a complete project with the simulation of the Turtlebot 3, some code to move around the robot, and it teaches you. And that's the way that companies can use it for documentation on demonstrations of their software, so that people can learn before they go and buy the real robot.
Right. What are the robots that you already have simulated or virtual versions of? I've noticed, I did notice Robotics, which makes the small humanoid robot. In your TheConstructSim, do you have something like the Universal Robots Robotics Robots Arm, for
Yes.
example? And
yes, exactly.
some examples
So there is,
some
yes,
of the robots.
that's it. Of robotics arms, we have, for example, the Universal Robot 5. Then there is also the WAM robot, that is also an industrial armed robot. Then also we have, for example, the hands of Shadow Hands. An industrial, let me think about, I think an industrial. Yes, there is also, what is the name? It's a Motoman also.
Yes, go
robot
on.
is there. Yes. And I think that's all in terms of industrial robots. I'm thinking you have a quite interesting, if you visit the page ROSjects.com, there you will see a list of example of ROSjects, and there is one that is a simulation of an industrial environment that is a mix of a conveyor belt with sensors detecting objects that go on the conveyor belt, then some universal robots, robotic arms, and even some autonomous robots that they move there. So the universal robot can not only grasp things, but also move along a rail. So it can move like this and then grasp things from one place, go to another, and put it on the autonomous robot, that wheel robot that will move around the industrial environment and bring the parts to another place. It's quite interesting. You can click there, and then you will get the whole simulation already running with a notebook with instructions about how to work with it. So you can create your own programs for testing that and controlling. And that's about industrial robots. Then we have drones. For example, we have Parrot drone. We have this type of collaborative robots that are created. For example, the Fetch robot, that is the one with one arm that can grasp things, or the Tiago robot, that is also a similar collaborative robot. And also another one that is called RB1 from Robotnik. It's another collaborative robot in the same sense. It's a base platform with an arm, with a Kinect as a face for detecting the objects. Then we have also wheel robots. We have many wheel robots there, from Turtlebots, of course, Pioneers. We have also Summit XL, many with different configurations, differential drives with 2 wheels, with 4 wheels. So, and we are including now more robots as we are contacting the different companies for including the robots in our platform. So anybody that wants to program for any robot that is ROS-based can go to our platform and start programming it. So in case that you are a company that you are around there and you would like to have your robots in our platform, then please contact me and it will be happy. We recently have added the robots of Neobotics company and also the company Usarion. And we are integrating every week. We are integrating new robots there.
Okay, and when did you actually start? I mean, I think I first heard of you about 2 years ago, but tell me when you started and how things have changed for you in the last few years and how you expect them to change going forward.
Well, when we started, it was in 2015. I had 100% clear that the future for robots and programming and environments is to use the web environment for programming. It's not going to be local computers and anything like that, because it's too small So robotics is going to be a lot more complex. The computational capabilities of a local computer is going to be very small. And we would like to have access to more cloud resources. So that was the main idea. And also I had very, very clear that the key point for making intelligent robots will be the simulations. And so at that point in time, so this idea was not very well accepted. So we had to suffer a lot because nobody understood our product in this case. And yeah, so it makes sense. So at that time, people was not using robot simulations as much. So we had to shift a little bit in order to get some revenue so to keep our company alive. And what we did was to create an online academy based on the same concept. So our online academy is called Robot Ignite Academy, and it's an academy for learning about ROS. And we use the same concept. We present the text with the instructions, the lessons about ROS concept. For example, let's say ROS perception, how to do perception with ROS, from cameras, from sensors, how to get the data from the perceived sensor, from the sensor. And so we have the lesson, then we have a zone for coding and a zone for compiling, checking files, and then we have the robot associated to that lesson. So the students can use this environment. Everything is on the web. You don't have to install anything. You go there, you create your programs, you compile them, you execute, you see the result in real time on the simulated robot. And then that makes a loop of feedback very, very fast for your brain. So you can learn ROS very, very fast. And so we started teaching their basic concepts of ROS, like topics, services, and that was quite popular because the normal way of learning ROS was going to the wiki, and that was quite dry to the ROS wiki. It's good. It was a good piece of documentation at its time, but now it's a little bit dry. So by using this loop of testing on the simulation at the same time that you are reading the notebook, all this very, very fast, people started to learn ROS very, very fast. So we moved to more complex subjects like reinforcement learning, deep learning, manipulation, autonomous cars. And then we have been creating some courses around there. Recently, we have released, for example, one course that it was quite demanded because people wanted to learn how to, so how can I create a robot and then ROSify that robot? Because it's okay if your robot already runs ROS, then it's okay. But how do I do my robot? How do I put my robot in ROS? And we have just released that this week. This course is quite interesting. So we move into the teaching. What the teaching was actually using the engine of the system that is based on the simulations in order to provide the simulations. So at some point in time, we were at some certain level on the academy, and then we decided, okay, let's go. Now it's the time to push on the programming environment for simulations. And that is when we took back again the ROS Development Studio. And that is the one that we are pushing now for making it available to anybody so that many people find it interesting and useful.
I find it really impressive that you built the program in the first place. I mean, obviously you're talking about the benefits and features from the point of view of the user, but from the point of view of the developer of this online application, I just wanted an insight into some of the challenges and difficulties, or maybe rewards that you found in the process of developing this and putting it online. I mean, the idea of building software is, you know, to me, it's very difficult, but not only that, but to make it available online through a web browser cloud-based or whatever, however you do it. I don't know. So some sort of, could you provide some sort of insight into that process of development and how you got to where you are? I mean, you are probably the only one who's doing this as well. Am I right in thinking that?
Yes. Well, developing for the web, it's quite difficult, and because you cannot, sometimes it's very strange things happen. So for example, there is a problem with the browsers. So every company that creates a browser wants to change the standard of the HTML or wants to add new features by itself. So some things that are available for one browser is not available for another one. So that's a pain, because at the end, if you don't have a unified web interface, then it's very likely that some things that work for somebody will not work for somebody else. And then what we are selling is the point that whatever you execute, somebody else will be able to execute in the same way as you execute if you do it in our system. Then for that, we have to start by defining the standards. In our cases, Firefox and Chrome. So even if our code can work in other browsers, in Safari, but sometimes you can get some strange behaviors. Take into account that we are using WebGL for the renderization in 3D of the simulations, for example, and some other techniques that are at the limit of the web development. So it could be that one browser is not still supporting this last technology instead of technology in web development, and then it will not work, our system. So for that reason, we have decided to create to support only Firefox and Chrome. And then for the development for the web, so the most difficult part is to find, in our case, is to find other people that know how to program in web. We are using Django, for example, for developing our system, and there are not many developers of Django. We decided Django because it was based on Python, and Python is very well integrated into ROS. So we decided that. But for example, Django environment framework for web development is not very common. So there are just a few. So the people that had been getting into our team, they had to start learning Django, for example. So we have been learning by doing, and that was a drawback in this case. But in the other case, Django is quite powerful. It integrates very well with ROS, and that's it. That's it. So we are happy to have taken Django. Probably Ruby on Rails also would have been a good framework for developing this application. But well, I don't know. I have no experience with Ruby on Rails. We were evaluating it at the beginning, and at the end, we decided Django for this reason, because it's based on Python.
I imagine that ROS will just get bigger and bigger, and more robots will incorporate ROS. Even the big industrial guys who have proprietary simulation programs and software, they will probably incorporate ROS more and more. But you know more about this area than I do. If you could comment on that.
Yeah, well, in our case, we are using Gazebo simulator because it's the standard in ROS community. So about the other simulators, there are other simulators that exist, like WeRobots, VREP, and others. And the problem is that ROS, as you mentioned, ROS is becoming the standard in robotics. So the people who want to use ROS and wants to use simulations, they just go straight into Gazebo, because Gazebo is natively supporting ROS. It's not something additional that you have to do into your simulations in order to incorporate ROS into. That's what happened in other simulators, that you have a special package system that you have to do and trick in order to get ROS running on there. And then about other big companies that may be creating the simulation, so simulators actually. So well, we don't know very much about that. I suspect that they are creating their own simulations, and if they release that to the public, then that would be great. See, if the simulators are better than Gazebo, this is great. If they release that to the public, is it only for them and for the clients? So I don't know. I don't see what can happen there. What I have seen is it's a really difficulty of people to change from what is the standard into other simulators, because I have seen this, for example, with Webots. At the beginning of our company, when we started in the ROS development studio, it was supporting both Gazebo and Webots. And Webots, I can tell you, it's a lot better simulator than Gazebo. It's very well done. It has been there for many years, and it was so it's a lot better simulator. It allows you to do many other things that Gazebo cannot let you do yet. But nobody was using Webots in our platform. The people that was using our platform for simulations all of them were using Gazebo. And I suspect that this is because of it's the easy way of going. When you install ROS, you already have Gazebo. When you are learning ROS, you are learning with Gazebo. So I suspect that that's the reason. Also, the open source Robotics Foundation, they are putting a lot of effort and money to improve the versions of Gazebo. And recently they are improving this a lot, very fast. So I really don't know what is going to happen, but that's how it looks. And now that you mentioned, I remember that they had a chat at the last ROS Con with it was a guy from Panasonic, yeah, and he showed me a very nice simulation based on that case was Unity, if I remember correctly. So I can see that there are a lot of simulations based on game engines like Unity or Unreal that are being created for very specific subjects. So it's kind of, for example, there are some specific simulators for autonomous cars, like the one that NVIDIA is creating based on Unreal, for example. Or for example, Carla simulator is a specific, it's quite nice, it's very close to reality. That is using, I think that one is using Unity, and it's for autonomous cars. So that's what I see. In this case, if you are on a very particular field, like it could be drones, or like could be autonomous cars, then maybe you will go to that specific simulator for that specific action. But in terms of general robotics and applying these simulations for the general robot, that anybody can create a new robot and start simulating it, then I don't see that Gazebo is going to be removed from the field so easy. So I think that we'll have Gazebo for a long time. I think that the best thing about, for example, the ROSjects that we were talking, the best thing is to experience them, I would say. So the best way is to come and attend any of our live classes that we do every Tuesday at 6 CET in our YouTube channel. And there you get to experience the power of this. So imagine that you have created your class, your simulations, your code, and you can make that hundreds of people at the same time as you can execute that code in the same circumstances as you, at the same time that you are experiencing. So that you will see how powerful the concept of ROSject is, because it goes beyond just sharing my Git. So here you have the Git, yeah, but you have the Git, you have to download your Git, then it doesn't compile, then the configuration for this library has to be this and that, but mine is this and that, and then it's a pain. You never achieve to get the results that the other person says that has achieved. Okay, so in that case, that's why ROSjects come to the rescue and allows you to forget about all that. Just go execute it, and then you will see that you get the same results. And of course, the ROSjects are open, so you can see all the code. You can download the code to your own computer, local computer if you want, and try to execute in the same sense. So you will have to configure your computer properly for that. But if you can do it, then it's okay. So it's not a closed system that is just created and then it remains closed there. So my final message, please come to our live classes, check it by yourself, and you will be convinced that how powerful this idea of ROSjects is.
Thank you very much, Ricardo.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.